So hello again. So today's lesson, we're not going to be talking necessarily about simplifying polynomials, but we're going to be talking about adding polynomials. And in reality, the two are very, very similar. So when we talk about adding polynomials, we can do it in, again, two manners. We can either use the tiles or add them symbolically. And in both cases, again, very similar to simplifying, maybe just one simple step in between. So if we want to use tiles, which is what the first example is going to be, we're going to need to represent each polynomial, combine and group the tiles of both polynomials, eliminate the zero pairs, and then rewrite the new polynomial. Four very simple steps, identical pretty much to the simplification. In this case, I have an addition of a three-term polynomial with a different three-term polynomial. So the first thing I want to do is I want to represent each of the polynomials, which are held in the brackets. So the first one is 2 times x to the power of 2 plus x minus 5. So I'm going to represent that using tiles. I'm going to have two x2 tiles, which are blue because it's not a negative number. I'm going to have one green rectangle, and I'm going to have 5 red unit chips because it is a negative number. This is the first polynomial, or that first set of terms in brackets. Adding to that x to the power of 2 minus 2x minus 5. Again, I'm going to represent that polynomial in tiles. In this case, I'm just going to put it underneath because I'm going to run out of space if I keep on going. I have one blue x2 tile, two red x tiles, and then a minus 5 unit tiles. So I have my first polynomial on that first row, and then the second polynomial on the second row. Now comes time to group similar tiles together, which I've currently done. So all the x2 tiles are together, all the x tiles are together, and then all the unit tiles are also together. We're now going to move on to eliminating the zero pair. So in this case, in the x2s, I don't have anything I can eliminate because I only have blue. I don't have a red one that can offset it. In the x tiles, though, I do have a red and a green. That means I can actually eliminate them. And in the unit tiles, I don't have any different colors, so they're going to stay all there. Using what's left, I can then rewrite the polynomial, or the addition of the two polynomials. As I have 3 blue x2 tiles, I'm going to write 3x2 minus the 1 red x tile, so minus x, and then I count my little unit tiles and gives me minus 10. So this is how you can actually add polynomials together. Again, it's very similar to the simplification process. So we have the two polynomials in this case, we can simply remove the brackets, and then we proceed with simplification. Without using the tiles, pretty much, again, exact same thing as simplification. We're talking about removing the brackets. We don't have to do anything else because it is an addition. We're going to identify like terms, group together like terms, combine them by adding the coefficients, and then rewriting the new polynomial. The last lesson I showed you how to simplify polynomial without tiles using a table format. Now I'm just going to go with a different method. So again, you can choose which one you prefer, but the logic behind it is the same. So in this example, I have a 3-term polynomial added to a 2-term polynomial. So first step I'm going to do is I'm going to remove the brackets. Now this, if you remember from the last of simplifying polynomials, it looks exactly the same. So then we get to proceed, as we always do, with the simplification of a polynomial. So my second step is to identify similar terms. Last class, I would have done this in a little chart. This time I'm going to use colors to represent similar terms. Now what I'm going to do is I'm going to group them together. So all the same, in this case, color or the same variables with their exponent are together. So I've just switched the terms around a bit. And then from here, I can combine the terms. As I then can just drop down the 3x2, I have a minus x plus 4, which would give me a positive 3x. And then a minus 10 plus 15, which would give me a positive 5. And then this would be my final polynomial.